So we are doing lesson 5.4 today with the last about 21 minutes of class, so we got to focus. However, this lesson's pretty easy. It's talking about two new concepts. So yesterday we learned about medians and altitudes. Today we're talking about centroids and orthocenters. Can someone remind me, what are the two special things about a median? A median has endpoints at what and what? Who can help me? What's a median?
The midpoint and vertex.
Midpoint and vertex. Thank you, Gavin. So median of a triangle is a segment whose endpoints are a vertex and the midpoint of the opposite side. And I actually gave you an example right there next to us. So A is the vertex, D is the midpoint. Together they make a median. Now this is a new word that you haven't heard though. This was on your homework and this is the one thing I told you to cross off. 3 or more lines that intersect at one single point are called concurrent. Ooh, that's not what I wanted. Concurrent. And so that's kind of a special thing. 2 lines always intersect, but a third line doesn't have to. Your third line might come here. It could go like just through this one over here. But if all 3 lines intersect at exactly one point, that's concurrent. And that point at which they intersect is called the point of concurrency. And so concurrency was the word that was on your homework last night that I said, we haven't done that yet. You don't know how to do it. Skip that part. But today we're learning about 2 special points of concurrency. And the first one is when we look at medians. So if I'm looking at all of the medians in one triangle, all of the medians are concurrent at a point called the centroid. So I think of centroid like the center of a triangle. There's some interesting math behind it. So the centroid, that point where the 3 lines intersect, is 2/3 the distance away from each vertex to the midpoint of the opposite side. And in other words, that means that each centroid divides the median into a 2-to-1 ratio. And the centroid is closer to the side of the triangle than it is the vertex. So let's go look at an example. I know I'm not great with ratios and fractions, and I know you guys might struggle a little bit. If it says it's a 2-to-1 ratio, if I like break down all of the numbers as far as I can go, then it would mean that like the distance from D to C would be 2, and the distance from C to J would just be 1. The whole distance together would be 2 plus 1, which is 3. And so that's why I said 2/3 or 1/3 before. So you can think of it as a ratio of 2-to-1, or you can think of it as like 2/3 to 1/3. You can think of DC as being twice as big as CJ. So like 2 is twice as big as 1. There's a lot of different ways for us to like kind of work in our brain to find that number. But we're going to do 3 examples real quick with actual numbers, and hopefully that helps us kind of ground ourselves in what the right answer is. So the first one says, if DJ equals 15, then what is CJ and what is DC? So if DJ equals 15, well, we knew before that DC was, like if DC was 2 and CJ was 1, then that means that the whole distance is 3. CJ is 1/3 and DC is 2/3. So I can divide by 3 in order to figure out how much CJ is. CJ is just 5. Now, we could think of doing 2/3 of 15, or we can say, okay, DC is twice CJ, so 2 times of 5 is 10. And that makes sense because 10 plus 5 is equal to 15. CJ is 5, DC is 10. Any questions so far? Now you can think if I give you the whole distance to divide by 3 and that's going to help us, but sometimes I don't give you the whole distance. Sometimes I give you other parts. So like the next one I gave you HC. So H to C is right here. That's from the centroid to the side, which is the one side. That's my 1/3. To get FC, I'm going to have to do 2 times that to get to 14. And then that makes FH either 3 times my HC or whatever 14 plus 7 is. And both of those numbers are 21. We're dealing with multiples of 3 here. So CF is 14 and HF is 21. Any questions so far? Okay. And then the last example I gave you is CE. And CE is actually one of the 2/3 lengths. It's from the centroid to the vertex. So that's the two-thirds, I guess, of the whole thing. What I think is the easiest thing is to remember that they're at a fraction of 2 to 1. So that makes this CE twice as much as GC. So if we divide 18 by 2, that number would be my GC, which is 9. Then I could find out what the whole distance is by adding 9 and 18, and that's 27. Or you can multiply 9 by 3, and that's also 27. Either one is correct. All right, I went through that a little quickly. Does anyone have any questions? Want me to talk about that anymore? Okay, I'm gonna keep going then. The next problem we have, or the next part, is about properties of the centroid. And so the centroid divides each median into a 2 to 1 ratio. Okay, we already talked about that. And then the centroid is what we call the balancing point of a triangle. This might not be a relevant like reference to you, but I remember when I was younger, I had this like paper like airplane or bird, and you would put like the point on your finger, and then the bird would be like over here, and it would be like balanced on your finger. Also, you can think about a balancing point as anything, any object you pick up that you put just one finger on and it stays balanced. So you could even do it with like your pencil or your stylus now. So you may think like, I might think my stylus is right in the middle, but like the end with the cap is a little bit heavier. So I need to kind of cheat my finger over towards that side in order to fully balance it on one finger. A balancing point is if I had like a triangle, I don't have a triangle, but if I had like a paper triangle, what's the one point that I could put my finger on to balance that triangle? And that point is the centroid, and we can mathematically find that. Because it's the balancing point, it always lies inside the triangle. I couldn't put a finger on the outside of the triangle and expect to balance it. It would just fall to the ground. So the centroid always is inside the triangle. And as I just said, it can be calculated by doing this. x1 plus x2 plus x3 divided by 3, and then y1 plus y2 plus y3 divided by 3. This is basically the midpoint formula, but instead of a midpoint, it's doing midpoints with 2 points and you find the average of them. I'm taking the 3 points of the triangle and finding the average of those x's and of those y's. This is the only like math, algebra calculations we're doing today. So that being said, let's go down to the figure and let's do that. We'll do the formula first, actually. So let's do the formula first. Use the formula to find the coordinates of the centroid, okay? So I've got 5 and 1 and 9. So I'm going to do those all added up together, divided by 3. And then now I'm going to do the y's, 7, 1, and 1. So comma 7 plus 1 plus 1 over 3. And try to solve that way. All right, add up what we see. 5 plus 1 plus 9, that is 15 over 3. 7 plus 1 plus 1 is 9 over 3. Oh, that's nice, easy numbers. 15 divided by 3 is 5, and then 9 divided by 3 is 3. Let's draw on the picture and see if we get that same answer. If you're given a coordinate plane like this, for sure draw on it. It actually even has all my midpoints labeled. They're the H and the G and the J. So that's nice. I don't even have to physically find midpoints. And I'm just going to connect vertex to midpoint. Vertex to midpoint. Vertex to midpoint. And they should, and again, we're not all perfect, so yours might be a little bit off, but on a picture like this with grids, we should be pretty on. They all intersect at this point right here, And that point happens to be 5, 3. Perfect. That's exactly what we just found algebraically. I love that. Again, that's the only calculating you need to know or you will do on this. Questions so far? Okay, I'm gonna need a little help over here. I've got a diagram kind of like our homework, and I need to figure out what the median is. Who can tell me what the median in this picture is?
Is it AD?
It is AD. Very good, Billy. A vertex, B midpoint. AD. And somebody else, find the altitude. Actually, sorry, is there an altitude? And if so, what is it? Is there an altitude? Actually, what makes it an altitude? What two things are important for an altitude?
Is it a vertex and a right angle?
Very good, Kamara. Do we have that here?
Yeah.
Where?
CF.
CF, awesome. So CF, we have a vertex of C and we have a right angle of F. So that line is my altitude. We're gonna use that on the very next slide. So that is great that we're previewing that. My last question is draw a midsegment in the diagram. What makes a midsegment special? Like what are the two things in a midsegment? What are the two endpoints of a midsegment?
Midpoints?
Midpoints, very good, Ella. And then what are my midpoints here?
E and D.
Very good. So I can connect E and D, and that would be my midsegment. So ED, it says draw it on the diagram. I also wrote it in case I needed help. As Ella said, midsegments come from midpoint. So because I have these midpoints of E and D, I can connect them to be a midsegment. Okay, awesome. I'm gonna go off of right what Kamara was saying about the altitude on the next page. So altitude of a triangle goes through a vertex of the triangle, and it is perpendicular. It makes a right angle with the opposite side. So I'm gonna write perpendicular here. Makes a right angle. And I've got a nice pretty picture over here, vertex, 90 degrees, all that fun stuff. Okay, as we talked about yesterday, an altitude is the same thing as a triangle's height. And the altitude can be on the inside or the outside of a triangle, and it could also be a side of a triangle. Now this is different than the median, which is always on the inside. My altitudes, when I draw all three altitudes, they will either be inside the triangle, on the side of the triangle, or outside the triangle. And the point of concurrency when all three altitudes are drawn is called the orthocenter. Orthocenter is kind of a weird word, but I remember orthocenter and altitude both start with vowels, and median and centroid both start with consonants. So I think that that helps me keep it straight. Those are kind of weird words, but we're only learning 2 of them, so hopefully we'll be able to be okay with that. The last thing we're doing is drawing all my altitudes. I'm sketching the points of concurrency for an acute, a right, and a obtuse triangle to see which one's on the inside, which one's on the outside, and which one's on the triangle. We could spend whole days on this, but we're just gonna sketch it pretty quickly. We still got about 7 minutes of class, so I don't think this will be too rushed. So let's zoom in on the acute triangle. Remember, we go from vertex to perpendicular. So I want to go from vertex to the opposite side. It looks like right about there is a 90-degree angle. If we were in class, we'd have protractors and compasses, and we'd do all this exact measurement, and it could take a full day of class, if not more. We're just guessing. So you may not have a perfect 90-degree angle, but we're just trying our best. I'm gonna do this from all of the vertexes. So over here, it looks like, I think that's pretty close to a right angle. And then from this one, they should all cross. So especially since we're just sketching, looks like mine's not great, but it'll do for now. My third side's not necessarily exactly a right angle, so I must have messed up somewhere. But they should all intersect. So make sure that all of your points intersect, because this point of intersection is that orthocenter. Just for kicks and giggles, I'm gonna draw really quick what the centroid would be here, which is the median, which is the midpoint of all of the sides. So vertex to midpoint, you do not have to do this. You can just watch me. I think that's about the midpoint. Guess it's right about there, maybe. Again, I did not do a perfect job here, but where the orange points intersect, that's the centroid. So do you see how they're different points depending on the different lines that we're drawing? And in this case, my orthocenter is inside the triangle. Now we're gonna go do it for the right triangle. The right triangle is actually pretty easy because to go from a vertex to a line that's perpendicular to the other side, well, that's just simply one side of the triangle. That's just the up and down side right there. If I do the bottom vertex, well, that's just the bottom side of my triangle. I'm gonna zoom in because the vertex from the right angle is a little bit tougher, but it doesn't really matter where this line goes. I think that's about a 90-degree angle. If I were to extend this line over here, the point of intersection, the orthocenter is on the sides of the triangle. It's actually one of the vertexes of my triangle. So this one is on, not inside, and also not outside. I know I'm moving pretty quickly, but any questions so far? Okay, the last one we're doing is an obtuse triangle, and I'm gonna look at the example that was given to us. The orthocenter is this point on the outside of the triangle. It's actually good that almost all of us are doing this on our iPads because you can see that for the example that's given to us, ABC is that like pink little triangle right here. If it's not colored in, maybe color it in. This shows me that some of my altitudes are on the outside. So the altitude from A is on the outside of my triangle. Same with B, it's on the outside of my triangle. C is fine, C goes right there. It stays inside the triangle, but we need to extend the line out to see where they cross. So that's what we're going to do on the example we have down here. Before I draw it, I'm going to extend the sides of XY and of YZ. I need to zoom in a little bit, sorry. If I want to find out where they're perpendicular, I need to extend the sides out a little bit. Ooh, that's bad. You may need to physically move your paper because I can't just free eye it or eyeball it as I go, I guess. When I draw my altitude from Y, it will stay inside the triangle because I have to go over here somewhere. I think that's about a right angle. But I do want to extend that line out this way, just because they're going to intersect actually up in this area somewhere. When I draw my altitude from X, if I try and stay inside the triangle, there's no way those are right angles. So I have to go outside, outside, outside. It looks like right about here, I think. It's trying to tell me it's a right angle. I believe that. And then the last one is Z. Again, if I try and draw from Z to the side XY inside the triangle, there's not a right angle at all. So I have to keep going outside, outside, outside. Again, these points should meet. So I'm gonna guess right about here. That looks about as right as I can get it. And this orthocenter is now outside the triangle. Centroids cannot go outside the triangle. Altitudes can go outside the triangle. Okay. I know I went through that kind of quickly. Does anyone have any questions or want me to explain like the line or something again? I may ask you to sketch this, but the biggest concept I want you to know is like that altitudes have a point of concurrency that's called the orthocenter that could be outside or on or inside the triangle, depending on which type of triangle it is. I can go back into my back these notes if you want, but I do want to scroll over to the homework really quick. So this homework is, I'll make a little do assignment thing in a second, but the first part is doing the centroid math that we talked about earlier. Then there's some mid-segment stuff. There's some special segments like what we did yesterday. As I said, homework is completion, so it's my expectation that you try it every day. If you don't know what's happening, we do actually have Flex right after this, so if you want to join my Flex Zoom, we can talk then. And then also, we correct this in class. So my ask is just you try this on your own so you know how to do it when we have a quiz next week on Tuesday. But also ask questions, and then this gives you a chance to actually know, like, did I know it on my own or did I not know it on my own when we go over questions as a class together. Okay, anything else? I'm gonna stop sharing my screen. I'm gonna stop recording.